direct conversion of methane to methanol at ambient conditions has been a dream reaction for the industry, and Thrunnel achieved that reaction through a breakthrough in biomimicry. Thrunnel biomimicked compound Q, which is the most powerful oxidant found in nature and the only compound ever observed in biology to contain two non-heme, high-valent, anti-ferromagnetically coupled high-spin iron. The intermolecular distance between those iron atoms is 2.46 angstrom, which is the shortest observed intermolecular distance in all di-iron clusters studied in biology. So this is a structurally unique compound. Add to that is the unique dynamicity between different valency and electron spin states that makes it almost impossible to mimic. The figure on the right shows the structure of Q compound in two different configurations. In the upper configuration, the low spin iron atoms are shown in blue. In the lower configuration, the high spin iron atoms are shown in green. The animation in the middle shows the fast periodic oscillation or alterations between the two configurations. With every alternation, a CH bond in methane is excised, as symbolized by the scissor icon cutting through a CH bond in the methane molecule. It happens as follows. When the iron adopts a high spin state, shown here as green colored atoms, its lowest unoccupied molecular orbital, also known by its acronym LUMO, descends down to collect an electron from the ground state of the half-occupied molecular orbital of oxygen. To get the idea, think of the LUMO of the iron atom as a magnet that attracts electrons only when it comes close enough to it. The magnet must be close to an object to attract it. The same way, the unoccupied orbital of the iron must come down close to the oxygen's occupied orbital to collect an electron from it. This is shown in the small coil spring animation on the left bottom side of the figure, where the iron atom's orbital moves down and up in energy levels with an arrow representing the electron spin, where the downward arrow represents the low spin state colored in blue and the upward arrow represents the high spin state colored in green. And that high spin state is the state where the iron electron orbital falls down towards the ground state of the oxygen to extract an electron from the oxygen. You might have heard the quote, "It is okay to fall down so long as you pick something from the ground when you get up." That is exactly what happens here. Every time the iron atom's electron orbital falls down to the ground, when it adopts a higher spin state, it picks up an electron from the oxygen's orbital. This causes the OO bond of oxygen to split. Then one oxygen atom is reduced to water by a 2-electron reduction, and the second oxygen atom extracts a hydrogen atom from methane, giving rise to a methyl radical and a hydroxyl OH group, which react together to yield methanol.